Okay, so in this video, we're going to continue doing some basic mole calculations. So in the last video, we talked about what a mole is. And basically, the mole is the SI unit for quantity, and 1 mole is defined so that a mole of anything contains as many elementary entities as there are atoms in 12 grams of carbon-12. And it just so happens that that value is a value called Avogadro's number, okay, which is given to you in the IB data booklet, so you don't necessarily need to memorize the value, but it's approximately equal to 6.02 times 10 to the 23. And so, just like you would say, like a pair represents 2 or a dozen represents 12, you could say a mole of a quantity represents Avogadro's number of that quantity. Okay, and so we kind of did a basic calculation um, in example 1. Okay, so let's move on talking about mole calculations. So we know that the weight, or I should say the mass of an atom is very, very small. Here you can see that one carbon atom has a mass of about 1.9927 times 10 to the negative 23 grams, which is a very, very, very small value. But a mole of carbon atoms, I'm assuming this is carbon-12 atoms, has a mass approximately equal to 12 grams. And so that 12 grams actually has a name. And what we would say is that we would say the molar mass of carbon-12 is about 12 grams. In other words, a mole of carbon atoms has a mass of about 12 grams. Okay, so this concept of molar mass is, like I said, it's exactly what it sounds like. Molar mass basically is like a conversion factor. If you imagine like unit conversion, it's basically a conversion factor that tells you, um, how many grams do you have in 1 mole of that chemical or that, yeah, that chemical. Okay, so just to kind of recap, the concept of the mole is useful because 1 mole contains a set number of particles, whether those, are atoms or molecules or donut holes or whatever. And so rather than talking about the motion of individual atoms or molecules, we can talk about how giant groups of atoms and molecules behave. And I said this before, but the molar mass of an element is the mass, either in grams or kilograms, that 1 mole of that element consists of. And so carbon-12, for example, has a molar mass of about, well, I guess exactly by definition, 12 grams per mole. And so we would write grams per mole like this, and that means that if we have 1 mole of carbon atoms, carbon-12 atoms, that is 6.02 times 10 to the 23 carbon-12 atoms, it would have a mass of exactly 12 grams. Okay, that's what molar mass is. It's a conversion factor. That's it. So let's just do some basic calculations with this concept of molar mass. Okay, so example 2 says the molar mass of sodium is about 23 grams per mole. Calculate the mass in kilograms. Watch out for that unit conversion, by the way. Calculate the mass in kilograms of a sample of sodium which contains 5.8 times 10 to the 24 atoms. Okay, so keep in mind, molar mass is a conversion factor. And when you're doing any type of conversion factor, you always start with your given. You don't start with your conversion factor. And so people have a tendency to approach this the wrong way. They think they should be starting with the 23 grams per mole, but this is just a conversion factor. You always start with what it is you're trying to convert, which is this. Okay, so we want to know the mass of sodium that has that many atoms. Okay, so let's think about this. I have 5.8 times 10 to the 24 sodium atoms, so Na atoms. And I know that 1 mole of atoms of sodium has a mass of 23 grams. I actually know that 1 mole of anything has 6.02 times 10 to the 23 of that something. And so if I have 6.02 times 10 to the 23 sodium atoms, by definition, that is 1 mole of sodium atoms. Okay, and the reason I am converting to moles is because I know the conversion factor in terms of grams per mole. And so 1 mole of sodium atoms has a mass of 23 grams. And then once I get into grams, I can get into kilograms just by dividing by 1,000. Okay, so let's see. Uh, Sodium atoms cancel, moles cancel. And so in my calculator, I'm doing 5.8 times 10 to the 24 times 23 divided by 6.02 times 10 to the 23. And that gives me 221.6 grams of sodium. And if I just divide that by 1,000, I get the answer in kilograms. That's 0.22 kilograms of sodium. Okay, and that is the answer to my question. And you've probably done calculations like this before in chemistry. This is just kind of like a refresher for those calculations. Pause it there if you need to look at that some more. Okay, so just to wrap your head around how big a mole is, because it's a giant number, and how small atoms and molecules are. Example 2.5 says the molar mass of water is about 18 grams per mole. Calculate the number of water molecules and the number of atoms in a cup of water holding 6 grams of water. Okay, so a couple things. Number one, you might be thinking, why is it asking for the number of molecules and atoms? Aren't those the same? But they're not, because remember, water is H2O. And so one water molecule of water, because it's H2O, that's 2 hydrogen atoms plus an oxygen atom, is actually 3 atoms, sorry. One molecule. Not, I don't know why I wrote mole. One of the biggest things that people have issues with in chemistry is confusing moles and molecules. And I understand why, because molecule, the first 4 letters of molecule spell mole. And so it's actually kind of like unfortunate, I guess. Moles have nothing to do with molecules. A mole is a counting number. I've said that before. Okay, it's just, I don't know if it's a coincidence or if it's just unfortunate naming, but molecule and mole are not the same thing. Okay, that's like saying like dozen and donuts are the same thing, even though like they're two separate concepts because you use them like together sometimes. I think some people like misunderstand what a mole is because they think it has something to do with a molecule. It doesn't. They just happen to be used uh, in similar situations. Okay, but they're not the same thing at all. So one molecule of H2O is 3 atoms, is what I was getting at. Okay, so don't confuse moles and molecules. Completely, well, not completely separate, but separate concepts. Okay, so here we have the molar mass of water is 18 grams per mole. Again, molar mass is a conversion factor. That's not something you start with. That is not a given. That is a conversion factor. Okay, we are asked to calculate the number of water molecules and atoms in a cup of water holding 6 grams of water. So we have 6 grams of H2O. First of all, I know that in 18 grams of H2O, there are 6.02 times 10 to the 23 H2O molecules. How do I know that? Because that's the molar mass. That's like the definition of what that is. Now, if you're confused by that, let me add that extra step in. Maybe I'm jumping ahead. Okay, because the molar mass is 18 grams per mole, 18 grams of H2O is equal to 1 mole of H2O. And 1 mole of anything, no matter what that thing is, in this case H2O, is about 6.02 times 10 to the 23 of that something. Okay, and so if I do this calculation here, I will get the number of water molecules there are. And then, keeping in mind that for every 1 water molecule, I have 3 atoms, I can answer both questions. Okay, and so if I do this calculation, I do 6 times 6.02 times 10 to the 23, divide by 18, and I get about 2.01 times 10 to the 23 water molecules. Now, how many atoms is that? Well, each of those molecules is H2O, so each one has 3 atoms. So if I multiply by 3, I get 6.02 times 10 to the 23 atoms in my cup of water. And you might think, like, that's strange. How did it end up being 6.02 times 10? Well, I just happened to choose the number to work out that way. That's a coincidence. Don't overthink that. Okay, so those are the two answers to the questions. Pause there if you need to look at it some more. Okay, so let's try to do a few calculations on your own. Okay, so example 3 says, can you swim in a billion molecules of water? So a billion times a billion is 1 times 10 to the 18. Okay, so we have 1 times 10 to the 18 water molecules. Okay, we're given, so that's the given. We're also told that the molar mass of water is about 18 grams per mole. By the way, in an IB physics question, you would always be given the molar mass. You can usually find that by looking at a periodic table, but you're not given a periodic table on the IB physics exam, so you would usually be given that directly in the problem. Okay, so basically we're asked if we had 1 times 10 to the 18 water molecules, how much mass is that, and can you swim in that? Okay, so try to do example 3 on your own. Okay, so let's see. 1 times 10 to the 18 water molecules. Oops. H2O molecules. I know that, so I want to find mass. So I know there's 6.02 times 10 to the 23 water molecules. Wow, I almost misspelled molecules somehow. Molecules in 1 mole of water. And I know, because I'm told the molar mass, that 1 mole of water has a mass of 18 grams. So let's see if I do this calculation. 1 times 10 to the 18 times 18. I typed that into my calculator wrong. 1 times 10 to the 18 times 18 divided by 6.02 times 10 to the 23. I get 2.99 times 10 to the negative 5 grams of water. Now, is that enough to swim in? Just to give you an idea, if you go to Sonic and you get like a drink and you take a little piece of Sonic ice, a tiny piece of Sonic ice has a mass of about 1 gram. Okay, this is like 10,000 times smaller than that. Can you swim in that? No, not really. Okay, and so a billion sounds like a lot, but this is just to kind of give you a sense for how small molecules are. So pause it there if you need to look at that some more. Okay, so we are going to do one more calculation problem, and then we'll do a few more in class. Okay, so example 5, this is actually from a past IB exam. Okay, and I'm going to give you a big hint on this type of question in case it ever comes up on the IB exam or on your test. It talks about carbon-12, and it talks about silicon-28. And at some point in the future, we'll talk about what exactly that means. But when it says carbon-12, you can assume, just for the sake of this problem, that carbon-12 has a molar mass of 12 grams per mole. And when it says carbon-28, you can assume that silicon-28 has a molar mass of about 28 grams per mole. And so it doesn't say that's the molar mass explicitly, but you can assume that in these types of problems. It's not technically true, but that's what the IB wants you to assume. Sorry, that's grams per mole. Okay, so keeping those conversion factors in mind, I want you to try to answer example 5 on your own. The question says, what is the mass of carbon-12 that contains the same number of atoms as 14 grams of silicon-28? Try to do example 5 on your own. Okay, so this is a past IB exam question. And I want to tell you that IB multiple choice questions, at least in science, you're not allowed to use a calculator. And so all the numbers are chosen so that you don't really need a calculator to do any of the calculations. Okay, and so just to show you that that's true, let's think about this. If I have 14 grams and the molar mass is 28 grams per mole, that's basically saying I have half a mole of silicon 28, right? Because 14 is half of 28. So if I have half a mole of silicon 28, what does that have to do with the number of atoms in carbon 12? Well, let's think about this. 1 mole of anything has the same like value, right? It's equal to Avogadro's constant. So if I have half a mole of silicon atoms and half a mole of carbon atoms, it's the same number of atoms. Now, it's not the same mass, but it's the same number of atoms, which is what the question is asking. Okay, so if I have half a mole of silicon 28 and I want the mass of carbon 12 that has the same number of atoms, that basically means that I want the mass of carbon 12 that has half a mole. Well, a full mole would be 12 grams. Okay, so what is the mass of carbon 12 that would have half of a mole? Well, that would be half of 12, which is 6 grams. Okay, so that is the answer to example 5. We can do some more calculations in class, but hopefully seeing a couple calculations involving molar mass give you an idea of what types of problems you might see as far as mole and molar mass calculations go, and hopefully these calculations are familiar to you anyway from chemistry. All right, so we're going to go ahead and stop this video here. As always, please let me know if you have any questions, and I'll see you guys in the next video.